Today we'll begin with a new chapter, and the name of chapter is circles. So in continuation with the revision of theorems of circles, next is tangent-secant theorem. In our last session we have done 13 theorems of circles. We'll take another 2. Tangent-secant theorem. As per this theorem, if a line is a tangent and other line is a secant, again as per this theorem, if a line is tangent, other line is secant, then the angle formed, this is the angle formed, is half of intercepted arc. Angle formed is half the intercepted arc. The important point to know is one line has to be a tangent, other line has to be a secant. One of the line has to be a tangent, other line has to be a secant. So if we are naming angle as ABC, this point as D, angle as ABC and interior point as D, as per tangent-secant theorem we can say that angle ABC half measure are ADB. So given to us BC tangent in both the cases, BC is tangent and AB is secant. AB is secant. Then we can say angle ABC is equal to half measure of arc ADB. The reason for this is tangent-secant theorem. The next one, angles in alternate segment theorem. Angles in alternate segment. This is the next theorem. As per this theorem, circle, tangent, secant, the angle which is formed is equal to angle formed in an alternate segment. As you can make out, these two angles will be equal. Same way, in this circle, tangent, secant, angle formed will equal to angle in a alternate segment. Now this other angle has to be on other side, not this side. These two angles are equal. If we name angle as ABC and this point as D, angle as ABC and the point as D. So given to us, for applying angles in alternate segment also, there has to be a tangent and secant. Given BC is a tangent, AB is a secant. Then by applying angles in alternate segment, in both the cases we can say angle ABC congruent angle ADB. Reason, angles in alternate segment theorem. Angles in alternate segment. So students, you need to know how to identify tangent-secant theorem, when to apply tangent-secant theorem, and more importantly, application of angles in alternate segment, where angle is congruent to alternate angle. Angle is congruent to alternate angle. Next, we'll start problem set question number 24, circles, Maharashtra state board. Now, in this sum, you will observe how nicely theorems like inscribed angle theorem, theorems like cyclic quadrilateral theorem, angles inscribed in the same arc, isosceles triangle theorem, how nicely these theorems are used to solve the problem. So gradually you need to pick up. This is one of the higher skilled base sum, which is of 5 marks. So we'll be taking this sum. Given to us one triangle ABC. This is problem set question number 24 of Maharashtra State Board. Given to us there is one triangle ABC. Now in this triangle ABC, these two parts are congruent. In triangle ABC, AB is congruent to AC. Then also mentioned there is a point P on line AC. This is given to us. There is a point P on line AC and B and P is joined, extended till point Q. Extended till point Q. Such that, condition given to us, such that angle ABQ and angle ACQ are congruent. Angle ABQ and angle ACQ are congruent. So I'll mark this angle also. These two angles are congruent given to us. Then we need to prove angle AQC is equal to 90 degree plus half angle BAC. 90 degree plus half angle BAC. So I'll write the given part also, which what all is known to us. As I said, this is problem set question number 24. Now the special thing is, figure is not given to you. Question is given to you and you have to draw the figure. That means by reading the statement, you should know how to draw the figure also. Triangle ABC. AB is congruent to AC. Angle ABQ congruent to angle ACQ. This is also known to us. We need to get this answer. That is angle AQC is equal to 90 degree plus half angle BAC. So I've already told you, we'll be using angles inscribed in a same arc, cyclic quadrilateral theorem, isosceles triangle theorem to get the answer. So we are making a construction. Construction is we are joining AQ. Join AQ. We'll start with the proof. First and foremost, we'll take this triangle. Now in this triangle, AB is congruent to AC. The result is angle ABC congruent to angle ACB. Isosceles triangle theorem. Triangle ABC, AB is equal to AC given. Therefore, result is angle ABC congruent to angle ACB. Angles opposite to congruent sides. So angle ABC is congruent to angle ACB. Also, we can write angle BAC plus angle ABC plus angle ACB is equal to 180 degree. The reason is sum of the angles of triangle is 180. Sum of 3 angles will be 180 degree. Any triangle, if you add 3 angles, you get 180 degree. Therefore, angle BAC plus. Now look at this. Angle ABC is congruent to angle ACB. Angle ABC plus. This can be replaced by angle ABC 180 degree. Angle BAC plus angle ABC will give you 2 angle ABC 180 degree. Therefore, 2 angle ABC is equal to 180 degree minus angle BAC. We got this term this side. Therefore, angle ABC equals to 180 degree minus angle BAC upon 2. Therefore, angle ABC equals to 180 degree upon 2 angle BAC upon 2. Many of you gets confused over here. Now this is A minus B upon C. When we write A minus B upon C, this can be written as A upon C minus B upon C. We are splitting the term. We can split the term, right? Therefore, angle ABC 90 degree minus half angle BAC, or you can write BAC upon 2. One of the equation we got. The answer which we are looking for, in that we have angle AQC equals to 90 degree plus half angle BAC. Angle ABC is equal to 90 degree minus angle BAC. We haven't got the answer, but somewhere we are close to the answer, right? Now, after this, these two angles are congruent. Again, we'll do some basics. Have a look over here now. Say there are two arcs. I'll be drawing it here. There are two arcs. Rather, there are two angles. Say these two angles are congruent. Now we have done the theorem, angles inscribed in a same arc are congruent. अभी ये दोनों एंगल congruent हैं. अगर सपोज यहां से एक सर्कल होता, एक सर्कल ड्रॉ किया होता मैंने, we could have said angles inscribed in a same arc are congruent. Now we are using converse of this theorem. कौन सा वाला? Angles inscribed in a same arc are congruent. अभी ये दोनों एंगल हैं, ये एक ही आर्क में इंस्क्राइब्ड है. अभी इसका हम लोग कन्वर्स यूज कर रहे हैं. ये दोनों एंगल इक्वल हैं. कन्वर्स क्या हो गया? ऑब्वियसली, डेफिनेटली इसके ऊपर से एक सर्कल ड्रॉ हो सकता है. इसके ऊपर से वी कैन ड्रॉ अ सर्कल. जैसे मैंने अभी ड्रॉ किया, एक आर्क ड्रॉ किया मैंने और कंप्लीट किया तो सर्कल ड्रॉ हो जाएगा. इसका मतलब when two angles are congruent this way, we can draw an arc like this. These two angles are congruent. This means we can draw an arc like this. Can you make out? This means we can draw an arc like this. Okay. Now, if arc can be drawn from this, these 4 points will become coincyclic. So I am writing this way. Angle ABQ is equal to angle ACQ given. Therefore, now as I said, these two angles are equal. Therefore, points, which all points? A, B, C and Q. These 4 points becomes coincyclic. Why coincyclic? Because we can draw an arc. We can draw an arc. Rather, we can draw a circle. Now, if I can draw a circle, just use your imagination. We will come to conclusion that quadrilateral ABCQ is cyclic because these 4 points are coming on that circle. Which points? ABCQ. And which quadrilateral will become cyclic? ABCQ. This quadrilateral will become cyclic. Therefore, quadrilateral ABCQ cyclic. Right? Now when ABCQ becomes cyclic, we can apply cyclic quadrilateral theorem. Cyclic quadrilateral theorem says that sum of opposite angle is 180 degree. Therefore, we can say that angle AQC plus angle ABC, which are opposite angle of quadrilateral ABCQ, is equal to 180 degree. Second equation. First equation, we write the reason for this, cyclic quadrilateral theorem. Now look at first and second. Instead of this ABC, I can replace this value, and if I replace this value, we can easily make out जो हमारा नया इक्वेशन बनेगा उसमें एंगल AQC रह जाएगा और एंगल BAC रह जाएगा. Again, when angle ABC का value is replaced by 90 degree minus half angle BAC, the new equation what we will get, that will have only two terms. Which two terms? Angle AQC and angle BAC. Angle AQC and angle BAC. That means the answer which we are looking for, the terms which we are looking for in the answer, we will get only those terms, and that will lead us to the right answer. Therefore, angle AQC plus, now instead of ABC I am writing this term, 90 degree minus angle BAC is equal to 180 degree. This we got from first and second equations. Therefore, angle AQC. Now, rest of the things we want on other side. So all terms I will shift on other side, equals to 180 degree. This 90 degree goes other side, minus 90 degree, minus half angle BAC, other side, half angle BAC. Angle AQC, 90 degree plus half angle BAC. This leads to our answer. So as I said, first we have applied isosceles triangle theorem. Second, we have applied sum of angle of a triangle 180 degree. Third, we have applied angles inscribed in a same arc are congruent. In other words, if two angles are congruent, they are in a same arc inscribed, they are inscribed in a same arc. So as angle ABQ is congruent to angle ACQ, they are inscribed in a same arc, and that arc has points A, B, C, Q, which I have mentioned. So angles inscribed in a same arc theorem. Then after that, we got two equations and the final answer, and cyclic quadratic theorem also in between. Okay, so from this, once I have done this, obviously you have to do practice once, twice, plus you also need to make out which all theorems we are using and which all theorems we can use again and again. So once you look at this sum, you should be able to make out यहाँ पर कौन कौन सा theorem applicable हो सकता है and which we can apply to get the answer. Problem set question number 8 for circles. Question is, two circles intersect each other in point x and y. So I draw two circles and they are intersecting at point x and y. This is the first circle, this is the second circle. So these two circles are intersecting at point x and y given to us. Then question goes this way: secant through x and y intersect one of the circles in A and D. So one secant is drawn from x. So I have drawn one secant, and there is one more secant drawn from y. That also I have drawn. Question goes, and the secant through point y, again there is a secant drawn, and that is intersecting one of the circle in point B and C. Condition is A and B are on opposite side of line DC. A point, B point, B point, C point. Question is, point A, point B are opposite to line DC. That means if I draw a line DC, A and B are falling on opposite sides. In other words, this cannot be your point B. If this is your point B, this will become line DC, and if this becomes line DC, A and B point are lying on the same side. But the condition is point A and B are lying on opposite side of line BC. We need to prove AD is parallel to BC. AD parallel to BC. Construction. Again, in this sum, figure was not given to you. By reading the question, by understanding the question, you have to draw the figure yourself, which becomes a bit challenging because 90% problems are along with the figures. Just 10% you need to draw figures of your own. So थोड़ा सा वहाँ पे challenge आ जाता है, right? Construction. As we need to prove AD is parallel to BC, so I join AD, I join BC. Now why to leave this XY? So I join XY also. Rather be required to join XY. It's not key just because X and Y points are lying, and that is why I'm joining XY. This will be required, so I've joined XY also. Construction. Join AD, BC and XY. So this I have used dotted lines because this is the actual construction. AD and BC as it was given in the problem, so I haven't used dotted lines. Otherwise, whether you use dotted lines or whether you don't use dotted lines, that makes no difference. Proof. Very simple. What we'll be doing is, we'll be using cyclic quadrilateral property. One, we'll be using cyclic quadrilateral property. Second, we'll be using property of parallel lines. When we prove two lines parallel, what are the properties comes into picture? That we are going to apply. Got it? One, cyclic quadrilateral theorem. Second, those properties like alternate angles, corresponding angles, interior angle test, those properties related to parallel lines, that we are going to use. Proof. Points A, X, Y, D are coincyclic. We can make out, it's given to us. Secants, point X, Y intersecting. In other words, ये जो points हैं A, X, Y, D, ये सर्कल के ऊपर है, एक ही सर्कल के ऊपर है. अगर ये चारों पॉइंट एक सर्कल के ऊपर आ गए तो पॉइंट्स हो गए कोइंसाइक्लिक. सो मैंने मेंशन किया A, X, Y और D पॉइंट कोइंसाइक्लिक है. A, X, Y, D पॉइंट कोइंसाइक्लिक है. Therefore, quadrilateral A, X, Y, D becomes cyclic. Why? Because points are coincyclic. By definition of cyclic quadrilateral, अगर points coincyclic है तो figure जो drawn होता है वो cyclic quadrilateral है. This we have done it before. So AX YD cyclic हो गया. Now when AX YD is cyclic, right? I can say this angle. Don't you think this angle is an exterior angle? This angle, interior angle, opposite interior angle. Therefore, I can say angle A congruent to angle BYX. Reason? Exterior angle of a cyclic quadrilateral. So these two angles are equal now. Again, points B, C, X, Y coincyclic. These 4 points are on a circle, same circle, so they are coincyclic. Therefore, quadrilateral B, C, X, Y becomes cyclic. Therefore, if it becomes a cyclic quadrilateral, obviously sum of opposite angle is 180 degree. Therefore, we can say angle C plus angle BYX 180 degree. Angle C plus angle BYX is equal to 180 degree. This is our second equation. Reason is cyclic quadrilateral theorem. Look at 1 and 2. If you look at 1 and 2, we can come to conclusion angle C plus, instead of this BYX, we can write angle A. How we got this? From 1 and 2. Now look at angle C, angle A, 180 degree. That means there is a transversal which is making 180 degree angle. Transversal CA is making 180 degree angles with two lines. Those lines are BC and AD. लाइन AD है, लाइन BC है. ये एक ट्रांसवर्सल है और वो ट्रांसवर्सल 180 डिग्री एंगल बना रहा है, इंटीरियर एंगल. If it happens, we can say lines parallel by interior angle test. Therefore, AD parallel to BC. Interior angle test. That's it. So points to capture, points to remember. 1. Exterior angle of a cyclic quadrilateral theorem. 2. Cyclic quadrilateral theorem. And 3. Interior angle test, which is required to prove lines parallel. One more activity which I want to give you. Say AC and BC are intersecting, then also you can get the same answer. Over here, AC and BB are not intersecting. If these two secants are intersecting also, then also we can get the answer. That will be a different case which we haven't taken over here.